Hello and welcome to today's class. Today we're going to handle set theory as part of our series, and we're starting by a definition, and our definition is we're going to define what a set is. As you can see here, we are saying that a set is a defined collection, group, aggregate or class of objects, meaning that this set is, let's say, like something that has several things. For instance, let's call it A. So you are going to have a set, and this set has a collection. A collection might mean it has several elements, and these elements must have a certain property or a certain characteristic that makes them be part of that set. Another thing to note is that a set is written in capital letters. A set should be well defined. So but now this set will have a class of objects. We can call it objects or elements, meaning you're going to have a set A, and this set has elements, let's say X, Y, Z, W. Another thing you need to know is that when we are writing sets, we don't use the normal brackets. We are going to use the curly brackets. Curly brackets are the ones that are used to represent a set. And now the next statement says that these objects are called elements of the set, and they are specified by two methods. The first method is the listing method. For example, we are saying we have a set A, and this set A has elements. Let's say these elements are members of the alphabet. That is there. That's how these elements are defined. Say X, Y, Z, W. These are members of a set because all of them are alphabets. That's the first method, listing method. We can say A is equals to 1, 2, 3, 4, 5. All of these are natural numbers. So you see they are well defined. This is the list method, whereby you're just listing the elements. And now another method is called the property of its elements. For example, say we have set A, which we are given here, and we don't want to write X, Y, Z, and W. Or maybe let's say we don't want to write A, B, C, D, E, and F. We can say that this set, we're having a set A, and this set A contains the first 6 elements of the alphabet. First 6 elements of the alphabet. So instead of writing A, B, C, D up to F, we're just going to state the characteristic of this set, because remember that a set must be well defined. We can also say that, let's say we have another set A. Instead of writing 2, 4, 6, 8, and 10, we can say we have a set A, and this set A, the characteristic or the property of its elements is that all the first, or let's say all the even integers between 1 and 11. Now we're having a set. You see, now the first case we are listing the elements of the set, and in the second case we are giving the property or the characteristic of the elements of these sets that we're going to have. So those are the two methods that are used to define. Those are the two ways that are used to define sets. Another thing you need to know, we have some symbols that are going to be used. For instance, we can write X, and then you're going to use that symbol. this symbol simply means X is a member of A. X is a member of A. Or alternatively, it means X is contained in A. X is contained in A. And now we also have another symbol here. This means X is not a member of A. X is not a member of A. Or alternatively, it means X is not contained in A. X is not contained, meaning that we have a set A, that set has elements, and X is not one of them. That is for the second case. Another definition that we have is the definition of an empty set. And one interesting thing with set theory is that the sets are named. The name of the set somehow describes the property of that set. For instance, here we have definition 2, empty set. Empty means it has nothing. So if you're told that to define an empty set, it means a set with no elements. This simply means set with no elements. A set with no elements. It's denoted by a symbol phi or two curly brackets with nothing inside. This is an empty set. Another name for an empty set is the null set. So you can either say null set, empty set, it still means the same thing, that is a set with no elements in it. Another definition that we're going to have is called a subset. Subset. A subset, you can see the word sub and the word set. It means that it's a small set inside or a small set that has elements contained in a bigger set. Anyway, that's how I define it in simple terms. So you have a subset. We're going to say, assume we have two sets, and those sets, we're going to name them A and B. Remember, we have said that sets are represented in capital letters. So we're going to say let A and B be two sets. Now we have, if every element in A, if every element of A is also contained in B, then we say that A is a subset of B. If every element of A is an element of B, if every element of A is an element of B, then you can comfortably say that we say A is a subset of B. A is a subset of B. How do we write? We write A, and then that's the symbol for subset of B. For example, let me give you a practical example. We are having two sets, A and B. We are having two sets. Let's say set A has elements 1, 2, 3. And now we have a set B, and this set B has elements 1, 2, 4, 5, 3, and 9. We want to check, is A a subset of B? Our definition says if every element, meaning that in case one element of A is not in B, then A will not be a subset of B. But in our case, let's check. A has three elements, 1, 2, 3. We're going to check in B. Do we have element 1? Yes. Do we have element 2? Yes. Do we have element 3? Yes. So we can say that A is a subset of B. That's the definition of subset. And the same case applies, assuming if we have every element of B is an element of A, then we can say that B is a subset of A. Every element, meaning that no single element should be left out in the smallest set. And don't forget to use curly brackets and capital letters. Another definition, a very important definition that we're going to define, is called equal sets. And I've given you a secret that in set theory, the name of the set automatically tells you something about the set. So we're going to say if A is a subset of B. By now we know that all the elements in A are contained in B, and B is a subset of A, meaning all the elements in B are contained in A. Then A and B are equal. Then A and B, automatically they are equal, because the only way that B will be also a subset of A, it means they have the same number of elements, are equal. And now how are we going to write? And we write using the equals sign. Another definition is A and B are equal if and only if, this is a conditional, meaning that they'll only be equals if and only if they contain exactly the same elements. If and only if they contain exactly the same elements. If and only if they contain exactly the same elements. For example, we have for you to understand better, we have a set A, and this set A has elements 1, 2, 3, and 4. It has 4 elements. And then we're going to have set B. Kindly remember that the order does not matter. What matters is, does it have 4 elements? Yes. Are the 4 elements the same? Yes. Then these two sets are said to be equal. So in our case, we have 2 sets, and these 2 sets are A and B. We're going to check. In set A we have an element which is 1. In set B are we having 1? Yes. Our second element is 2. In B, are we having a 2? Yes. Our second element is 3. In set B are we going to have a 3? Yes. And we check the same 4. Then you can comfortably say that A is a subset of B, because all the elements in A are contained in B. And again, B is a subset of A, because all the elements in B are in A. Hence, A is equal to B. Another definition is the definition of a proper subset. Proper subset. Remember, in the first case, we have said we can have a subset, A is in B and B is in A, then they become equal. But now in a proper subset, we have a strict condition. We're going to say that if A is a subset of B, but now A is not equal to B, then we say that A is a proper subset of B. Then A is a proper subset of B, because we're having all the elements of A are in B, but now these two are not equal, and now we write using the symbol A subset B. Another definition that you need to know before we proceed in set theory is something we call the cardinality of a set. We're going to have a term, cardinality. We know that cardinality represents the number of sets, so we have cardinality of a set, and we define it as the number of elements in a set. The number of elements in a set. Number of elements in a set is the cardinality of a set. Then we write it as, we denote or we express cardinality of a set by n of A. That's the cardinality of a set A. We're going to use the straight lines to write cardinality of a set. For instance, if you're given set A, you have an example here. Set A has elements 1, 2, 4, 5, 9, 10. You are asked what's the cardinality of this set. You write, you'll just count the number of elements 1, 2, 3, 4, 5, 6, and then you can say that n of A is 6, meaning that our set A has 6 elements. Another important definition that we're going to make is called the singleton. We have another kind of set. This set is the singleton set. From the word single, single means strictly one element. So if you're asked to define a singleton set, then that means is from the word we can say a set with one element. A set with one element. A set with one element. That's a